Hello everyone. So today I'm going to explain about the async annotation. As we know, the Spring Boot or Spring MVC applications, so there is a one annotations, the @async. So that, like, what is the purpose of it, what is the main advantages of it, how we are going to use it, and like what is the process for using this annotation, and if we are going to use this one, then what kind of benefit basically we'll get. So today in this tutorial I'm going to explain about this async annotation. So it is a basically one kind of annotation that is, if you're going to use this one, then it will improve the performance optimization in a Spring Boot project. Okay, we can create our own executors and threadful also with that, but async actually make things much simpler and more things logical. Okay, so if we're going to use this async annotation, so if we're going to run our code in the background, so our main thread can keep, like, it's not actually without waiting, it will not wait for any tasks that about to finished. But like, it is important to use it wisely, as know its a limit, because if we are going to use it like in a not in a means in a good manner, or any means programmatically manner, then maybe we'll get some another issues which will break down the performance of these applications, or maybe we'll get some kind of out of memory issues. So if we are going to learn about the basis of this, like how we are going to use this async annotation in our application. So first of all, basically we need to enable async in our Spring Boot applications. For doing this, we need to add the enable async annotations in our class level, so that it will or maybe in our applications file where we are going to use this one, like the main class. So it will basically enable the asynchronous behavior for all the methods that are basically annotated with the async method. For example, if you are enabling any application, Spring Boot applications, with this enable async annotations, then for whatever the method we will going to create in our project, and if we provide at that async annotation top of the method, then it will behave as a asynchronous. But there are certain rules for how we are going to use this address async annotations. Means it's not simple as that, like, there is one method and we are going to directly use the async annotation so that it will behave as like asynchronous behavior. But there are certain rules that we need to follow. So first of all, we need to use these annotations. So either in the configuration class, or maybe over here there is a one annotation like this enable async that I'm showing over here, like this one, enable async. This annotation we are going to use over here. If you see, this is enable the Spring asynchronous method execution capability, similar to functionalities found in this Spring Tags XML namespace. Okay, and if we click on this, so you will get more detail about this one, like over here, like how it is working and all those things. So I'm not going into that. You guys can check this one. But just one thing, for enabling the async behavior, if you want to achieve, then we need to use the enable async over here. Okay, next we can create our own actually bean for specifying or configurations for method with whatever the method we have annotated with the async. So we can actually like set different types of parameters, like thread pool, code pool size, max pool, then queue capacity, thread name. So those kind of things or properties we can like uh, set over here. But while adding those informations or configurations through this, if is there any kind of, like, if we did kind of mistakes or something or misconfigurations, then it will give us out of memory soon. So usually we can put some kind of the logs over there so that we can understand, like, when the queue size is full, or maybe there are no more threads to pick up the new incoming tasks. So in that certain scenarios, it will like put those things. So how we are going to create those bin? Let me create over here one bin. So we need to use this bin over here, and then we need to use this public. Then it will be a thread pool executor. thread pool tasks, thread pool task executor, and here we can provide as a task executor. Okay, because it will obviously it will provide, it will do some kind of task, so that's why it's a task actually. So here basically you are going to create one object for this class, as you can see, like executor. Okay, and here we are going to create this object first. th I'm getting some issues over there. So this one is done now. Next basically we need to set those properties. How we are going to set those things? Let's see. Set core pool size. Okay, so here we can provide the core pool size, maybe 2 or 4 or whatever it is. Okay, then we can put set max pool size, whatever the max pool size, so maybe 4 or 5. Okay, next we can put the queue capacity. Suppose there is already thread is processing, so it should wait. So how many thread can wait? So maybe 100 or 200 or 400, 500, whatever we can provide over here. Then we can like provide some set thread capacity, thread name prefix. Okay, like we can provide some name, custom thread, for example, custom. Okay, hyphen. Next we can means suppose, as I was saying, we can put some logs over here if a queue is full or something like that. So here is suppose rejected execution handler. Over here we can like provide those kind of things. So it will be put that, or maybe instead of that we can put some kind of sys out. Okay, so you can mention like queue is full, thread queue is full. Okay, and then we can like we can initialize this thread, we can initialize this, and then from over here we can return this executor. So that means this executor creation is done now. Now like for example we can create some service class over there. We can uh, maybe for example in a certain project, if we consider certain scenarios, like if we're doing some kind of purchase something from the any e-commerce site, or maybe if we are doing some transactions from the bank, then we are receiving some kind of the OTP, or maybe some transactional message like you have done this transaction and your available balance this. Okay, or maybe you are getting some kind of the emails through in like in your mail account, whatever the mail account it is. So as you know, those kind of things, maybe email or maybe SMS or maybe some kind of the push messages, so those are basically event that actually we can send through some kind of the external vendor, right? Means those are not coming directly. Means obviously if we are going to sending some SMS, then it will be come through the telecaller some vendor. If we are sending email, then it will be a like SMTP vendor, and also push it's also be some vendor. So obviously those, if we are sending those messages, then it will be obviously take some time. But if we wait for the response of those services, then means it will block the response of something. For example, if we are doing some transactions and the transaction is successful and we are sending the SMS to the customer, so until or unless customer getting the messages and you're getting the response, so that particular service is still in the hold, or it will be wait to get the response from the particular vendor. So it will take time. So in those scenarios, basically we are going to send those SMS in a async way, means asynchronously, so that we are not going to wait for the response of the particular service. Those things actually run in a background, and once the response is get, then they are taken care automatically, means we are not doing anything. Okay, so we are just trigger those things from in our services, so that those services run in asynchronous mode, so that we don't need to wait for those services to complete, or maybe we're getting responses. So the email sending is one of them. So suppose if we're going to create any services, for example, let's say email service or something, and from there we are going to do means we are going to send some email. So for that, basically we need to annotate those methods actually as a async. Okay, so this is the means certain scenarios that we are going to used over here. So for as example, the email example is good one for this one, so I'm going to take this example for demonstrating like how we are going to use this async annotations over here. So suppose let's create another like class over here. So for example, the package name is service. Okay, and the class name, let's say email service. Obviously it should be annotated with at the service annotations. And over here, basically maybe we are going to create one service, let's say send email. Okay, send email, and it should be annotated with the @async, this method. Okay, so this is the like annotation that basically we are going to use for asynchronous behavior, those things. Now when actually you're going to using this async annotation, so it is very important to note like that we cannot call async method from within the same class. This is because like it will be lead to a means maybe kind of wrong assumption or something it will occur. So for example, like here is another method. For example, let's say test is a method. Okay, and from here if you are going to call this one, so then it will basically not worked over here. Okay, so this is the one thing. Instead of like what we can use, we can create the separate class, service class for our async kind of thing. Okay, so that will be better. Like we can create another class. For example, let's say uh, here maybe kind of what we can say, uh, redeem service. Okay, or maybe transaction service, transaction service. Okay, and here it will be a @service annotations, and from here we are going to auto-aware private email service. Okay, and here we are going to create another method, void do transaction. Okay, and from here email service dot, let's see what okay, it will be a public, so I'm deleting this one. So from this we are going to call this one send email. Okay, so that means we have created this, and from over here it will call this one. Okay, so this is actually approach that we can take in to call the sing method. So not this one, it will be a send email. Okay, okay, So this is the thing that basically we are going to use, means we can create the separate class for uh, create instead of means calling the async service from the same class. So we need to create another class which is basically responsible to do those things. So even also, now let's create one controller so that we can test from over here. So let me create one controller. Let's see, transaction controller. Okay, and it will be annotated with as a REST controller. Then we can provide one request mapping. Okay, and here we can provide the path, something like /API. Here we can create one controller like get mapping, public void get transaction detail. Okay, return success. It will be return type is string, and it will be a get mapping. Get/get transaction. Okay, so that we can like create a simple one. Okay, what we can do we can automate that service, this transaction service. Okay, transaction service, and instead of that, what I can do, we can call this one. Okay, dot do transaction. Okay, now what we can do, as this basically service call this one, so we can put something over here so that we can understand that means what we can do means once we'll call this one, so internally it will call this service and it will do this, send the email. Okay, that means we can actually receive the message this one immediately, but in the background, means in the console log or maybe in the background, it will say working on this part, working on this async thread. Okay, so here basically we can put some kind of thread, and then maybe we can use some kind of for loop just to uh, like index array, like it will be 100. Okay, and then here we can put sending email. Here we can put like sending email, and then here we can put some kind of sleep. Okay, thread dot sleep 10 millisecond. Okay, it will throw this exception. Okay, so that means what it will do from this one, it will also throw. Okay, and controller also throw. Going to call this one, calling this service, so internally it will call this, execute this method, and then in the background it will call this one, so immediately we'll get this response like success, but in the background you can see this will printing. That means this method actually is do the work. Okay, so if we start this application, then from the postman basically we can check. It will not take much time, it will start immediately. Tomcat started this one, and it started in HTTP port. So for better, I'm just clearing this console. Now from here the API, and instead of this we are going to use this get transaction detail. Let me re-verify. Transaction controller get transactions. Okay, So let me copy this one, get transactions. Okay, now if we call this one, okay, immediately we can see the success, but in the background you can see we're getting the like it was working. Okay, again if we call this one, okay, so let me put some IDs over here. Plus thread dot current thread. Let's check what it is print. Let's put it as 1 minute. Okay, now we can increase also the sleep time like 100 millisecond, that means 1 second. So instead of 100 we can like check with the 10 also, and here what it will do, it will basically sending email and it will print the current thread name. So what is the thread name? Basically the prefix was should be custom async thread that we have used over here, right? So that should be print over here. So now the console is cleared, so let me retry this one. You can see the success is over here, but in the backend you can see the this email thread is still going on, right? The sending email, and this is the thread name, the custom async thread one. This is the thread name, right? So you can see it's printed over here as I have like decreased from 100 to 10. So it's printed 10. That means we are getting the response, and but in the backend actually it's still working. So that means it is not blocking the particular thread, which is basically it immediately it will give us the response. It is not blocking. So that means it is internally or in the backend it is working whatever the work it is, like maybe sending the email, sending the SMS, sending the push, or maybe if we want to do some heavy operations in a database kind of thing, so in a backend we can do, but without blocking any from the front end or maybe in the client we are not blocking anything, we are just sending the response immediately so that it will not block. So this is the like benefit of this one async. That means it's work as a kind of thread working. Okay, means internally it is working. So there is another thing, like if we say, can we call this async method from another async method? Definitely no, right? Because async is already is a kind of one thread. So if we are calling another thread from that is we can call, but that is not looks like, right? Means maybe it's ended with some kind of the unexpected behavior because we don't know when the thread will complete the operations, right? So that is the thing. So that is not miss a good one. So because we'll get some kind of the unexpected behavior for this. In case of the transactional, as you know how we are going to manage the transactions, we need to use that the transactional annotations for managing the transactions. So obviously it's not possible to means use the async method from the transactional method because transactional annotation is working kind of a proxy kind of thing. So that's why it's not a good thing to use those things calling the async method from the transactional. Now uh, the blocking issues for this one, suppose maybe there is a any certain scenarios, maybe we'll have the like two tasks is working continuously async tasks. Now let's say like another task is coming, so uh, they will be queue up until the queue size is full. Like if we check this one, here is a 2 core pool size, so 2 already is working and the queue capacity is 400. Now already 400 is full. Now next is coming, then what it will do, that means and means it's not filled up, that means one of our tasks is already taking too much time to execute and it will basically blocked because of the external dependencies or something, right? So that means it will other tasks would queue and will not be executed fast enough, right? Because it's already taking more time. So this basically cause delay depending on the type of our application. So one of the option is to like we can create two types of the thread pool executor. One is for the heavy, like if it is a heavy task, and another is for the like normal tasks, right? That two task executor we can create over here, and we can provide the like name bin name, and whatever the tasks over here, like we can provide over here like uh, over here we can provide the name like what kind of task it is, like it's a heavy task or it's a kind of normal task. So based on that we can like name provide the name over here. Okay, so this is the thing that we can basically do. Even suppose uh, this method if throw some exception, and if we try to handle those exception in the from the upper, it is not possible, right? Because it's a non-blocking kind of thing, and those exception is not basically catch by those things, right? Because it will be not handled. So better to handle those exception inside of this async method instead of trying to catching those into the upper method or like in the exception hierarchy. So this is the thing basically. Or another thing is to like if we want to uh, return something from this uh, kind of async method. So over here like we can send something like maybe let me show you return, for example return string. Okay, uh, return success. Okay, so it will be return type of string, but instead of that maybe we can try future of string. Okay, now suppose if we throw some exceptions from over here, throw new, for example runtime exception, just for example. Okay, and here we can put some messages, exception occurred. Okay, so that basically we can get over here, like it will be returned kind of like future of string of those, future string, and here we can say result. Okay, and here basically we can put those things like result dot get. Okay, let me rerun. It's started already. Rerun from over here. So now you can see until or unless its result is completed, that means this is occurred, it will not get any responses. You understand, right? Means let me clear the response again. Okay, so what I did basically I uh, over here we have written from something over here from this async method, which kind of the future, and here basically we are getting those things in a service layer. That means it's a block now. So that means until or unless we are receive the result, it will not return anything. Okay, it will wait for something. So you can see I am sending the request. It's still processing until we are getting the response complete. Now the response complete is done, then it will we are getting the that particular exception over here. Now this is the thing. So that means we can block the things using the future of a string. So this is the kind of block, and if you're not going to use this kind of, means we don't need any response from the any kind of the mm, uh, async service, then it will work as an individual non-blocking kind of thing. So this is the basically thing that means we can use the future or this kind of things so that we can block those things. As a summary of these things, like this async annotation in Spring Boot is very powerful tool for improving the performance and scalability of any application that we are going to develop. And also it's like obviously it's important to use it with care, because it's a kind of there is some limitations that means also you should understand like how we're going to use those things. So this is about this async method, async annotations, that how we are going to use this one and what is the benefit of it. If you guys have anything, please do let me know in the comment sections. And thanks for watching. Bye bye.